Matematika. Today we're going to do 2.2a, change in linear and exponential functions. Linear functions and arithmetic sequences are somewhat like similar in such a way that we can look at their similarity in terms of the slope-intercept form of a linear function and the arithmetic sequence, which can be written in explicit notation by a formula. So if we try to look at the f of x equals b plus mx, the f of x here is the output value, while the b is the initial value, that's the y-intercept, and m is the slope, and x is the input. So where is the similarity that you can see in the arithmetic sequence? In arithmetic sequence, the a sub n is the nth term, the n is the term number, and a sub o is the initial first term. We call that as a naught, and d is the common difference. If you look at the initial value in the slope-intercept form, b, or you can have a sub o, is for the initial value. That is where we can see the similarity there. While m is the rate of change in the slope-intercept form, while the d is the common difference. Alright, that is where we can find with the similarity. So if there is an initial value in the slope-intercept form, there is also an initial value in the arithmetic sequence. If there is a rate of change, which is the slope in the slope-intercept form, there is also a common difference in arithmetic sequence. So when not starting, if there is no starting with an initial value, then we can transform this equation of fx equals b plus mx with the point slope form, wherein you have f of x equals y initial plus m times x minus x1, where you have a point of x1, y1 as the known point, and you have the slope. Well, with arithmetic sequence, the a sub n is equals to a sub k, that is the k term, okay, the nth term, plus d times n minus k. So a sub n is equals to the nth term, a sub k is the known k term, d is the common difference, n is the term number or the nth term, and k is the term number of known nth term. All right. That is where we can find the similarity. In a point slope, we have a known point, that's the coordinates, and m as the slope. While in arithmetic sequence, we have n minus k, that is the difference of the number of terms minus the k terms. Okay. By looking at the graph, we can have this graph as f of n equals 2x plus 1, where you can see the y-intercept here. In this graph, the y-intercept is 1. And then you can use by looking at which point you want to know, you can use the rise over run as your slope. Well, in this case here, If you look at this point where it corresponds, this can be your first term, second, third, and fourth term. And what's the difference from here? This is 3 and this is 5. So 3, 5, this is 7, and you have 9. So that means there is a difference of 2, 3 to 5, 7, 5 to 7, 7 to 9. And the starting point is 3. And you have the number of terms, you just multiply it with the nth term minus 1 for that, for the arithmetic sequence. So we could say that arithmetic sequences are linear functions. Why? So arithmetic sequence are linear functions because both have a constant rate of change, which is the slope and common difference, and an initial value, that is the first term or the y-intercepts. That is why there is a similarity of arithmetic sequence and linear function. Let's have an example. Monday has already folded 4 shirts before her shift officially begins at the clothing store. Additional information about the number of shirts she has folded of various times during her shift is given in the table. So if we look at the table before her shift, that it means that time is 0. She had folded already 4 shirts. Okay? So after how many minutes would that be? 15 minutes, she folded 19. After 30 minutes, she folded 34. 45 minutes, 49. 60 minutes, 64. All right. The first question is, state whether Monday's number of shirts folded represent an arithmetic sequence. Okay. So an arithmetic sequence, remember, will have a constant rate of change. Okay? Arithmetic, we must have to consider that and look at the situation in arithmetic sequence. So there should be a constant rate of change. So we're gonna check if we have a constant rate of change here. We can compare the values in the table and see how much the total ticket sales are increasing by each hour. Okay, so we have we try to get the difference. 19 minus 4, that's 15. 34 minus 19, that's 15. 49 minus 34, that's 15. 64 minus 49, that's 15. So the rate of change is constant, which is 15. Okay? That's a common difference. Right? So therefore, since the rate of change is constant, which is 15, therefore, this is an arithmetic sequence. Okay, I'm going to write it. This is an arithmetic sequence. Okay, let's have letter B. Determine the linear function that represent the number of shirts Monday has folded S of t as a function of time and t in minutes. So since S of t is given, so we could create a function of S of t for we call this the slope for intercept form. Okay, so we could create that as the slope times the time plus the y-intercept, where m is the slope, and b as the y-intercept. Okay, so from the table, let's look at the table here. When t is 15, the S of t is 19. Okay, so we can get the slope by doing this. The slope would be, if we substitute 19 for slope, 19 for S of t, and then m is the one we're looking for, and t is 15, then we could evaluate. Okay, we can do evaluation by using the slope y2 minus y1, and the t here is S of 0, we have that 4, right? Okay, so that would be 19 minus 4 over how much when it's 19? The minutes is 15 minus the starting point, which is 0. So using that, 19 minus 4, that's 15 over 15. So the slope is equals to 1. What does it mean that Monday folded 1 shirt per minute? One shirt per minute. Okay, so the y-intercept is the number of shirts folded at the start, which is t plus 0. So how are we going to determine the function? So the S of t will be the slope, which is 1 times t plus 4. This is the equation of the linear function that you're going to have. All right. Calculate the number of shirts Monday has folded in 90 minutes. Okay, so substitute t equals 90 in the equation. So S of t is 1 t plus 4. So that would be 1 times 90 minutes plus 4. So 90 plus 4, it will be 94 shirts. Okay, that she folded after 90 minutes. All right, let's have letter D. Monday shirt folding business is growing in 2023. She folded approximately 2,000 shirts each month. Between 2023 and 2028, the number of shirts she folded increased approximately at 3.5% per year. So according to this estimate, how many shirts did she folded per month in 2025? So how can we use that formula? Maybe we can write something like, okay, what would be the final amount that would be equals to the initial, the starting amount you had, and then times 1 plus the growth rate. Remember, in the exponential function, that is to the power of number of years. Okay? So in this case, the initial amount or the number she folded in 2023. Okay, so the initial amount is 2,000 shirts. It is happened in 2023. So the growth rate is given as 3.5%. What else is given? This is 3.5% per year. So when we convert that in terms of decimal, we move 2 places, so that would be 0.035. So the number of years, this is the number of years from 2023 to 2025. The number of years is 2. Okay, so we can use that for the final amount that is being asked. Okay, so the initial amount, that is 2,000, times the growth rate, that would be 1 plus 0.035 to the power of number of years, which is 2. So we'll evaluate. That would be 2,000 times 1.035 to the power of 2. Okay, using the calculator, multiply 1.035 to the second power times 2,000. You approximately get the value of the final amount is approximately 2,142.45. So according to the estimate, Monday folded approximately 2,142 shirts per month. So approximately 2,000, because we cannot have a 0.45 shirt. So we approximately that to 2,142 shirts per month in 2025. That should be the case there. What is the ratio of shirt in folding from 2025 compared to 2023. So we're gonna divide the number of shirts in number of shirts in 2025 by the number of shirts in 2023 to get the ratio. So in 2025, so this is the ratio, okay? So in 2025, she folded 2,142 shirts, while in 2023, she folded 2,000 shirts. So approximately, we have the value of 1, the ratio of 1.071. So the ratio of folding, the ratio of shirt folding in 2025 compared to 2023, I'm going to write it in words. The ratio of folding from 2025 compared to 2023 is approximately 1.071. All right. Let's have question number 2. The following functions are either linear or exponential. Which is it? And justify your answer. So first of all, if you are given a table, try to check if you have a ratio or difference. All right, so if we look at this, we have 1, 3, 9 as our y value. So we can have a common difference because 1, 2, 3, you have 2, and 3 to 9, you have 6. All right, so let's get the ratio. 3 divided by 1 is 3. 9 divided by 3, it is 3. So the ratio here is 3. Let's look at the input value. So what's the difference from negative 3 to 2? Or 2 minus a negative 3, that is 5 difference. So 5 steps difference. That means it is exponential. Okay, this is exponential. Why this is exponential? So you could start saying, because for each input, we have for each input, that is the x value, what is the input change of 5, right? Because there is from negative 3 to 2, there is an input change of 5. F, that is the output, changes proportionally its proportion by a ratio. We're talking about a ratio of 3. All right, let's have the next. 12 to 9, 9 to 6. Okay, 9 minus 12, that is negative 3. So we have 6 minus 9, that's negative 3. That means we have a common difference of negative 3 here. Let's look at 2 to 6. That's 4. 6 to 10. That's 4. So you could say this is, since it's difference, this is linear function. So what's the reason? Because for every for each input, that is the x, what's the change in input of 4, right? What happened to our function? The output value changes at a constant rate of negative 3. That's the difference. That's it. You just write down what reason why you think it's linear and why you think it is exponential. And it's very clear when we look at the table, the changes from the x value and to the y value, or the input value to the output value. Okay, let's do this. In each function, linear or exponential, identify the constant slope or ratio that causes the output value to change. Okay, by looking at this, of course, this is exponential. It's very clear, no doubt. This is exponential. So where can you find, because it's slope or ratio, so when it's exponential, you have a ratio. All right. So where can we find the ratio? Right here. This is the ratio. So the ratio is 1/3. All right. Y equals 6 plus 2x, or mx plus 6. Okay. So that means this is linear. So when it's linear, you have the difference, or you could say the slope. Where we can find the slope? Right here. This is the slope. That means the slope is 2. Here, this is plus 6, exponential, very clear. So you have a ratio. And what's the ratio here? Right here. The ratio of 3. All right. You have it. Let's say I add one more. Y plus 1 is 6, equals to 6x minus 7, 3. So what do you think? We don't see any exponential here. So this is linear, of course, where we can find the slope right here. That's the slope. So the slope of 6. All right. So let me give a summary before we end up. So an arithmetic sequence, always remember, arithmetic sequence is a linear function. Okay? Because it has a constant rate. This is the main point in this our topic for today. It has a constant rate of change. When the first term and common difference are known, then you could say a sub n equals a sub 0 plus d of n. And if it's not, when any term or common difference, this is unknown. I'm making a summary. If the first term is known and common difference, what can we use? We use the a sub n equals a naught, or initial first term, plus d times n. That's a common difference. When any term or common difference are known for any term and common difference. All right. So what are we gonna use? A sub n equals a of that k term, d times n minus that term. All right. This is a summary of this topic that we do today about the linear function and arithmetic sequence. Okay. Before we end up, let me say this. If I can do it, so can you. Don't forget to hit the like button and please subscribe. See you in my next video.